All right, so we have observed heating curves of substances. Like we observed water and its heating curve. What we did was we put a beaker of ice water on a hot plate and we turned it on and we had a temperature probe in it and we monitored that heating curve. And what happened was it was flat for a while, and then it went steeper, and then it was flat at around 100 degrees. So we wanted to see if the cooling curve would follow a similar trend. So what we're doing is I have a test tube in here of this clear substance. Now that clear substance looks like water because it's clear, but it's actually not. It's lauric acid. Now lauric acid has a melting point or freezing point, whatever you want to think of it as a 43 to 45 degrees Celsius. Right now, we're sitting at about 88 degrees Celsius. And so it's above its melting point, so that's why it's a liquid. And so it's this clear liquid. However, as a solid, what you'll see is, I don't know if you can see this or not, but it's white powder. And you'll see it later for sure. So what I'm going to do is I've got this beaker of just room temperature water right here. I'm just going to take this guy out and I'm going to drop it in there and then monitor what the cooling curve will look like. And so let me get my computer ready to go because I'm going to create the video of the graph that it makes. And so I'm going to click record. And then I'm going to click collect. And we are collecting data. So I'm just going to take this guy out like so. I'm going to fling this guy around here. Now the important thing about the cooling curve is I don't want the temperature probe touching the side of the glass. But right now it is, but when I submerge it I'm going to have to hold it to where it is going to stay pretty much even, not touching the side of the glass or anything like that. So I'm just going to hold it like that, and now it's just a matter of waiting. And so we're waiting, and the temperature is dropping pretty rapidly. If I can make sure that I'm holding it steady and looking at my computer at the same time, I'll read off temperatures as I go. Now, I wouldn't want to hold on the side of the glass because what you're observing right now, or should be observing, if the camera's good enough, you'll observe the white solid start to form. Now, it's going to start forming on the outside of the test tube first because that's where the cooler water is coming in contact with the glass. And so while you see right now white stuff on the outside, the inside is still pretty liquidy. And so we're observing pretty much the transition from the liquid to the solid state. And eventually it's going to be completely solidified. It's just a matter of making the transition to being a liquid to a solid. And once it's completely solidified, I won't be able to remove my go temp very easily. It's going to take some yanking if I wanted to get it out as a solid. However, I'm probably just going to warm it back up to get it out. And so now it's just a matter of waiting. I will say this, the freezing point of the lauric acid is about 43 to 45 degrees Celsius. Now we're getting close to that. It's about 47 right now. So I can let go of it now and it's completely staying in place because it's pretty much solidified. So what I want to do at this point is I want to make this even colder. Let's see what happens when I make it even colder. And so I'm going to just add a couple ice cubes to it. And I'll annotate on the graph where I added the ice cubes. I'm going to continue adding ice cubes. I'm going to add a whole bunch. And then I'll use my stirring rod to make sure that guy is evenly distributed. Right now it's about room temperature, and I'm just going to go ahead and stop it, just like that. And I do want to show you what the solid looks like. And so I'm going to take this out, and I'll show you here. There's that white solid that used to be a liquid. And I try and pull my go temp out, and it's not budging. So the graph, I'll put a picture at the end, but this is a successful cooling curve. Okay, so this is the finished annotated graph of the cooling curve of lauric acid. Notice on the left, this is where I started, and it was about 80 some degrees to start with. It started as a liquid, and notice how it's clearly the temperature is decreasing. What that means is the speed of the particles are slowing down. Then it gets to a point where it is going to freeze. And that's why it's such a flat line here from here to here. It starts flattening off right here, and then this is the point at which I could no longer, this point right here, that my mouse is over, that is the point at which I could no longer remove the go temp, which means that it is completely solidified. So then I added ice just to make it colder, and notice what happened. I started to get this steady, this very consistent decrease right over here. So what that means, this is where it's a liquid. This is where it's a liquid to a solid, or freezing, and here it's solid. So here, that is the completely annotated graph.